So, the number E, or is it a letter?
Who knows?
I'm confused.
The letter you're talking about.
Oh, man.
Oh, that's what that's
Okay,
called.
now we can get into all sorts of philosophical debates about letters and numbers, right?
Jesus.
And then I saw the joke board, and it said, then the devil said, let's put letters in math.
Yeah, I think I put that up there.
Very nice.
Letters and math?
What?
Math.
Uh-oh. You said
It's kind of ironic, right? M-A-T-H is made out of letters. Never mind. It's too deep for you guys. Way too deep.
No.
All right, so what's another letter
You know what else is deep? The hole that my
that you know represents a number?
I.
Pi, okay. Pi is what?
That's not even a letter. I said I. Yes, it is in the Greek.
You said I? Well, I heard pi. So that's what we're going with. Anybody want to continue?
I.
192.1415926.
53589799323.
Okay, that's good. Okay. How was pi developed?
Nerd.
How did we get that number?
22 divided by 7.
It's the circumference divided by the diameter, right?
Right, so in a circle, the circumference of a circle divided by diameter is the ratio pi. Okay? Pi is irrational. Do you remember what that means?
It
Never ends and never repeats and never patterns. Okay, if you have a patterning decimal, it's a rational number. You can make a fraction. Okay, so keep in mind. And then we can get into all sorts of, okay, there's too much murmuring here. All sorts of philosophical debates about whether that will actually ever end. Because we've got computers working on it 24/7 and they still haven't found the end.
How do they know if they find the end?
There will be no remainder on the division problem, basically. It's a division problem, right? So you get no remainder, no repeats, nothing. So, there are other mathematical letters that represent numbers. This is just the most famous, right? We're going to look at the next most famous is E.
Why is it so famous?
Okay? Because we use it a lot. Okay? E is approximately 2.71828.
That was good, though.
Okay?
When does E end?
E is also irrational, up to the point that we know.
Why don't we use E more?
Question.
Okay? Because pi is more geometric, E is more calculus-sick. I don't know.
So how?
Okay,
somebody
so-
just say E equals the big?
No. How is E developed?
Well, I bet you're gonna tell us.
I am going to tell you. E is this ratio here, 1. It's actually developed from what's called series and sequences. If you ever make it to Calc BC, we study these. Okay, 1/1 plus 1 times 2
Is it 1 plus 1?
Oh, yeah, that's 2.
plus
6.
Oh, 2. Oh my God.
You see the pattern?
1 times 2 times 4. What is D that comes up?
Okay, that is. Now, did I put a dot out the end? Okay, that is exactly E. That's an eraser. Okay, thank you.
So E is more.
This is approximately E. Okay, so know the difference. Remember, we talk exact, approximate a lot in math, right? If you write a decimal of either of these numbers, it's an approximation.
So
Somebody said 22/7. That is approximately pi.
yes. Do we have? Is there like a you know how there's like a pi on a calculator?
There is an E on your calculator.
No way.
Way. Dude, way.
Are you gonna show us how to get there?
E. Did you find it?
I see an E and a weird looking.
Right there. Second ln, and you're going to learn what ln means later this week. So if you hit calculus, second E.
No, I meant like pattern.
We, okay, E to the first obviously is what we just looked at, right? There you go. And the 1828 does not repeat past that, so don't get comfortable with that pattern. But that's where E is on your calculator. It's second ln. We're going to learn what ln and log, all these mean right here this week. All those mystery keys on your calculator, you're just kind of figuring them out piecemeal now. So that's E on your calculator. All right? E is very special. Yeah, keep telling yourself that. Give yourself a blue ribbon for doing nothing.
Yeah, but that is what society needs. Why deserve it? You tried.
You look sad. Let me give you a blue ribbon.
You look funny. You look funny when you get helmets.
You do a really good job banging your head against a wall. Let me give you a prize. That's the graph of e to the x. Okay? As an exponential, okay, just like everything else, this is just 2.71828 yada yada yada, right? So it's just basically that, approximately, right? Now, is this, as x approaches infinity, does this get less and less accurate?
Yes.
It does, because they are not exact, right? So you have to use e to the x to be exact. Your calculator will never be perfect on this one because it can't go on forever. It would run out of batteries. Or you would run out of life, both of which are undesirable, right?
Wow.
Okay. That was deep, I know.
That was.
So you're saying I can die?
We're waxing philosophical today.
Yeah.
Okay.
That one struck me.
Okay.
Show me the car back.
Where is that?
What? Yes, it is.
We can put
I was so relaxed too, because this was like the first time I got to lean out.
okay, remember last time we put exponential growth or decay in, was it r to the r to the t, right? We put that equation, exponential growth or decay, together, correct? Based on the percent rate of growth or decay, right? Okay. We can put this in terms of E. Okay. Right, so this is exponential growth or decay in terms of E.
Wait, how are you able to replace that with E?
Do you really want me to go through that with you?
Yeah.
Well, I mean,
We should probably, okay, if you want to be, what your book says, okay, K is a constant. Okay, growth or decay constant. It's not equal to R. Does that make it more clear?
yeah.
Because if you put R there, it does complicate things. Okay. This is a general, like if you're a biology guy or gal, these are two formulas you could use interchangeably. This one is used a lot, believe it or not. It's kind of creepy how well it works. Okay, it's very special.
Who figured it out?
Oh, goodness. You don't have a math history book back there? If you want to read it, I'd be more than happy to loan it to you. But I cannot answer that from memory because math history, not important to me. Okay, finance. Okay, if you're doing finance, This is continuously compounded interest. Compounded. Okay. So remember the last formula we had was compounded daily or monthly or yearly, right? Well, this is continuous. If you have a savings account, this is what you want. Continuously compounded. Okay. If you have a credit card, you definitely want monthly compounded, right? It's cheaper that way. So couple of equations that we relate to what we learned last time. So let's have let's take a principal balance on a savings account. Let's say you invest $10,000. Okay. A lot of you in your adult lives will get to that point. Okay, I hope all of you do, but some of you will be stupid at points.
I am one of those.
And cost yourself some money.
Caleb Frink is one of them.
Okay, let's earn. Let's go for 25 years at 6.75%
Each day.
interest. Okay, let's compare daily. You want to do daily?
Monthly to you.
We'll pick one of those.
Monthly.
Okay, let's compare monthly compound versus continuous.
What's continuous?
Continuously compounded interest. That's the formula I just showed you. R. And then this one was is that right? Yeah. All right, so you have monthly interest. What was our principal? Principal. That principal is the amount, initial amount, right? So 10,000. 1 plus the rate over number of compounds per year. And then number times 25, right? Because time is 25 years. All right, how much will that account have in it after 25 years? While they're calculating, the key here would be not to just let this sit, but to continue adding to it. So if you're adding money to it and your interest is continuing, that's when you get really big balances. Everybody got it? It's going to more than triple, maybe even quadruple, quintuple. You guys are the slowest typers in history.
I like you do it. Go for it.
I do it.
What's the 12.25 at the end? Or the
It's 12 times 25.
Yeah.
oh, 12 times 25.
Well, let's see it in months.
See, I don't even have to use a calculator.
That's usually what
Oh,
you do.
crap.
Yeah, I'm a cheater. It's 49.
Wow.
Do you want me to put that in the calculator
Yeah.
and show you?
Yes.
No, I know.
Okay. Whoops, it's not on. Okay, now we're in business.
What a loser.
I'm a loser, yeah. Okay.
Yeah.
You know what sucks about losing your hearing?
What?
Can't hear half of what people say about you. Huh, that's interesting.
Ah, the book was wrong, or you were wrong.
Oh, I would.
Loser.
Oh, okay. No, this is,
Forgot to add the one.
we did something different. I gave you guys choice, so the book is not right because the book doesn't have the answer. Okay, that would be my fault. So it's like 50. What did our calculator say? 53804.48.
Yes, sir.
Okay.
28. 538.
That's killing me. I'm killing myself here. 48. Take that. Okay. Continuously compounded interest. A lot easier to put in, right?
Yes.
So let's, all right, 10 E, and then this is the one I wrote up there before. Okay. So which method's best, right?
Continues by $200.
Yeah, there's not a big difference.
What's $200?
But if you're a bank, and that's $200 per person over the course of the 10 million people that you serve, does that save them a lot of money?
Yeah.
Doing monthly instead of continuous? Yeah. 10 million people, $200 a person? Yeah, it's like 200 million, $2 billion, right? Okay, so there you go. So these are basically, this is basically plugging and chugging on these problems. Okay, take what you know and plug it into the formula, and either algebraically solve for one of these or get the answer out the back like we did. Okay. We could ask this question: when will the account double?
Tomorrow.
Right? We could ask that question.
So you just put X in for the T. In theory, it should be at
We do not have the knowledge yet
40
to do this one.
years.
You need what's called the natural log. Okay.
40
Well, you need logarithms for both of these. All right. So this is not a question you'll be asked today, unless you want to just plug and chug it. But if you want to set this up, what's the amount? Yeah, 20,000 equals 10,000. If you want to do continuous, e to the 0.0675 t.
So what exactly, like?
Okay, so we're going to divide by 10,000, right? We know our algebra. And get 2 equals e. Okay, now this is where you haven't learned what a logarithm is. Anybody? Have you seen it? No? Okay. At this point, we're stuck because we don't know what. Unless you want to plug in t. What do you think t is? Take a guess. 7? Okay, plug 7 into your calculator here. See if it gives you 2. Right, 2 is the number you want this to come out to, right? So if you plug 7 in, let's try it.
What if I was right?
It's going to be close, I think.
Would you give me $1 million?
No.
Small loan.
Not 7 years, right? So
9.
let's try 8.
No, it's 9. I can guarantee it's 9.
Nope.
It's
Try again.
11.
I said 12 because it started with T.
Let's see if Mike is right. Nope.
It's 11.
I tried.
All right, we're wasting time now.
No, we're not. Just
It's
one more.
11.
Okay, 10's close. right?
10.5. 10.3.
11's over. Okay, you're going to be somewhere in the 10s, right?
10.5.
In year 10, like in year 10, your account will double in value. You could do, okay, so at this point you don't have the tools to exactly solve this. I could show you it is ln2 divided by, it's 10.27. Okay, so 10.3 was pretty darn close.
How did you do that? That was the wizardry.
Any questions? It wasn't wizardry.
Wizardry?
How do we solve algebra equations?
Plug and chug.
Inverse, right? So like here, the inverse of multiply is divide. Right? So what's the inverse of exponential E?
Negative.
Well, it just happens to be what's called the natural logarithm. And the natural logarithm of 2, and then you divide by 0.0675 and you're good to go. Okay. That is scheduled for Thursday, Friday, and it will greatly benefit you on the SAT, PSAT. This stuff will, all right? Tomorrow, so either tomorrow or Thursday we're going to do like an SAT day. I just haven't got it figured out. And then logs. So lots of SAT stuff this week. All right. Your SAT is Tuesday, right?
Yes.
You don't have math class Tuesday. You just have to take a math test.
Freshman everything, PSAT. Freshman, I hate you.
Today's Tuesday. Today's Tuesday. You know that.
Okay.
When is it due?
Tomorrow.
Oh,
Oh, we have a track meet. Don't we?
yeah, we should have this Thursday.
Don't listen to the starter. He's a jerk.
Yeah, that was another baseball game.
Yeah, we could do Thursday since there's track and baseball.
Thank you.
Thank you. Rookies look at this.
They only pick 11 from 1 through 7? Or?
Yeah, so in here, these are word problems. Okay, so like I was telling you, if you're going to be in biology, pick something that, if you want to do biology, pick something that's that direction. Or if you want to do finance, pick a finance problem. They're kind of limited. There's no engineering problems, I don't think. But there's sociology, customer service, psychology. There's physics. That's a good engineering. Oh, there is an engineering problem. There's a banking problem. There's marketing. Okay, so pick one.
I'll choose the odd one.